Guys, how are you? This is part 2. I'm going to pull it down so you can see what's in it and how easy it is to pull down, put together and pull apart and all that. We're going to speed it up for you so it's not too boring. And yeah, so this top hasn't been put on properly. There should be a nut under here as a stopper, and bring it down and adjust it to the right. Everything's got nuts on it to adjust it to the right height. Threaded bar, 10mm threaded bar, stainless. It's not magnetic. The insulation, this stuff here is to neutralise the electric fields around it. So I put that everywhere, and then the bars become a conductor, and the whole thing's earthed out. The bars become an earth as well because they've got sharp edges. But I'll pull it apart quick. The big thing I want to show you is getting this rotor apart. It is the hardest thing to do, so I will pause it, I'll loosen some nuts, and you just go through, loosen them all off. That's the only time consuming part, you have to unscrew these to come up. So I will do that, and away we go. I guess the first thing to do is take the top off. Top comes off. When you put this, make sure you drill these holes out 10.5mm or more, so you got heaps of root, makes it easy to get on and off. 10.5mm would be alright. I'm just going to basically start at the top, work my way down. I've used wires in here as my neutralizer and to take the power off. I forget what you'd call it, but anyway, I'm going to swap that to, when I put it back in, I have to do these little jobs on it. And I'm going to swap that to this flexible conductive rubber. So that's going to get swapped out. Hopefully it's still in good condition. I bought this a few years ago. For the neutralizer, there's my neutralizer wire that just pulls out. A couple of screws on top here. This I haven't finished either. This is the neutralizer, part of the neutralizer. So when I put this back together, inside this ring, I'm going to put aluminium in here and insulate it. So an aluminium ring, aluminium here as well, it'll act as half a capacitor. My neutralizer will come up and hit this. This will go around to the other side, which will I can tee into it at any point and get a neutral earth out of it. And righto, so that's that. These just slide out now. So here's your Holtz, top of Holtz type thing, and you can see how I've put it in, and it just slides in and out a bit. You just put it in place and it'll just sit there. There's no force on it, so it shouldn't have to move. This is my supply line, so this is what pumps up the rotor, and all it is a little wire. I have this slide, and it's supposed to be sticky taped on there. In to connect, I can push it in or out so that it connects with the inner rotor, and either touches it or it just jumps off. The plasma jumps off the end and charges it up that way. And you can pull it right out, and you can change the end, you can put a paper over it so it just filters through slowly. So that's that part that comes out. Here's the other side. So this is the other side I'm using. This can be earthed out. Either side could be earthed. So you can earth either. I just earthed them. I got wire mesh here, so aluminium frame, so I just earthed it out to that. It goes through the house, it's 50,000 to 60,000 volts, it'll find the earth somehow. Here's the other side. So this is what I use to charge the capacitor banks. So this one side used to charge the rotor, one side, it doesn't matter. One side's used for the other bit. The big thing, this has been designed to discharge. If the charges build up internally, this is the biggest problem I had thinking about this. If the charges build up inside this machine, you want it to be able to discharge somehow. So I made it so it would change polarity to suit it. So after a while, charges build up, it should discharge and recharge, and then pick up the new direction, and it'll change polarity. But it doesn't matter. This is AC that's coming through here. It's current running through charging and discharging capacitors, so the current's just going back and forth. It doesn't matter if it's positive or negative or what it's doing. It's just a current in a wire. A current that then has to get across a gap. You can put more resistance in or take the resistance out. I did this. This contains a plasma. So your aluminium foil inside your little brackets. That'll stop any leakage here. You got aluminium foil under the wires. I got aluminium foil over the wires. The electric fields on the outside, it can't leak. So they just pull out. And all I've done here is I've grouped 3 or 4 together and shoved them through the hole. And it keeps everything nice and neat. This wire here is linking up. It's the way, when you work it out, you'll see why. This one here and this, so this corner and this corner are the same polarity, and this corner and this corner are the same polarity. So I link them up just to keep it easy. I'm just, trying to make it easy. And like I said, the transformer could end up, my original thought was the transformer will sit on top. So I have this, work my way up to the top. But when I noticed that there was a magnetic field here, and a transformer is all about changing in the magnetic field, I thought it might be good. The magnetic field here should be rolling out and rolling down by the time it gets to the transformer. So the magnetic field should be going this way, and that might even be making it worse for me. I don't know. The other side, so we're going to do the other side. There, so that same deal, aluminium in there, so there's another couple little parts. So that's there, they're ready to come apart. And the way I would do this, that stays on, everything stays together. This thing now lifts up, should lift, I should say. Here we have it. A capacitor module. So I think that's pretty cool. And if you look under here, there's the rotor. I've used a 4-sided thing to do it. And so you'll put that out right of it so you can see the rest of it. So now with this, same deal, these can just pull out. Just pull out. I got a plug there, and I'm not going to pull my rotor apart. I'm happy with my rotor. I'm going to leave it, so there's no point me getting into that. But yeah, I've got the capacitor modules off, and but all this stuff, because now I could just pull that out too. That's just sitting there. Right, it could pull up. Oh no, I've got a nut. I have put a nut in there actually, which I will undo. Aluminium again, and you just get no leakage this way. If you don't use the aluminium, it's going to leak through the plastic. And it's going to burn your plastic out. So the aluminium helps to protect the print. And that's right. Oh yeah, all of this stuff I've bought a special, some plastic clear lacquer, and I've sprayed all of this stuff with lacquer, a couple of good coats, 2 tins I've used on this, to try and protect it from the ozone. And all of that. So that's it. That's ready to pull apart. So because it's sitting on the bench now, I can just gently open it up. I've made, on the print that I uploaded onto the internet, I've made the grooves in here 1 millimeter higher, and I'm going to check it, but I'm pretty sure I've made the discs a millimetre small. The plates, the capacitor plates, are a millimetre smaller. The top one's too loose. This top one's a bit too loose, but I haven't worried about it because it doesn't matter. It goes in, and then the ring screws in place on top and keeps everything in the right place. It can't go this way, and it can't go that way, so it's got to be in the right place. Anyway, so here we go. You ready? So here's a capacitor plate. What I did with this capacitor plate was I lacquered it. It wasn't good enough. I went and bought a roll of stick-on plastic that you use to cover your school books, and I didn't fold it around the edges of some of them. The one that I'm most concerned about is this one down here. I put green tape on it. Number 6, he's given me grief, and it's this one plate. I got to pull the whole thing apart to get to that one plate. But I'm going to have to check all of them. I probably haven't wrapped around the edge. I haven't put the film over and wrapped it. And what's happening is its breakdown is coming up around the corner and getting on this top. This is where the wire is. So the breakdown, I think, is in this edge here somewhere. Sharp. It looks like there's a sharp bit of aluminium there. And it may have melted through this stuff. So I'll pull that off and I'll rub it down. What I should have done, I used wire because of 2 reasons. One, it's insulated. You know, probably not enough, but it's insulated. I could have, there is a step here, but all I did was I put the wire in and then I put a bit of aluminium foil over it to stop it from leaking. And then I put a bit of sticky tape over it and then I wrapped it. And the reasoning being that after all I started thinking, because of the capacitance, you don't want to, there is a spot here to lay down, you could paint in a line or put in aluminium, but I didn't want rough edges and I didn't want to lose capacitance outside. It's all about capacitance, so I didn't want any capacitance or minimum amount of capacitance outside of the capacitor plate. I'll give you, actually, so I know, I made them a bit bigger. So at the bottom they're about 20 mil and at the top they're about 40 mil and overall they're 40 mil. So that'd make it 30 mil by 30 mil by 40 mil. 3 times 4 is 12. So that's 12 square centimeters. There's 2 of them. So it's 24 square centimeters, and then on the other side of the disc, there's another 2 of them. So it's 48 square centimeters per disc. There's 10 discs, that's 480 square centimeters of surface area per capacitor bank. Alrighty, and there's one of your sides. So when you do it, drill out, make it easy, really drill it out with a drill, 10 mil, 10.5 mil. Here's the rotor. Here's the rotor. Here's the Holtz disc on top. Here's the rotor disc in here. You can see them in there. And what I'm going to do is pull this apart. Oh, this is all just sitting there too. So that top comes off. Because the velocity is, it's spinning, there's no forces up and down. So this top should, oh, see, there it is. Oh yeah, when it's all done and all put together, you just put a no-lock nut on top, and it's all, that bearing holds in the bearing from underneath. This is what I needed to show you, is, so this one here, you'll see that this one is, they're all stacked that way, and this one isn't. And what's happening is I'm putting that wire, goes in here, where's my little feed wire? This thing goes in like that, and that wire feeds in the charge in here and sprays the charge onto the ring. I've had to put a spacer ring in here to lift it up 5 or 10 mil. There's a little spacer ring in there, which I can show you. Pull that apart. So that's the top one. It's the other way. Here it is here. And I've done alfoil, I've done electric paint, but what I should have done was gone around the edges and rubbed them, because you can't see if you missed a spot. And what's happening is there's little sharp edges all the way around here, and I'm only getting 10,000 volts or 20,000 volts on this disc. I should be getting 100,000 volts or more, depending on the insulation, you know, how good you can get your insulation. But anyway, these little sharp edges, so that's the problem with aluminium. You get sharp edges, and it's a bit of a nightmare. So I'm going to spend a day or 2 days rubbing all the edges. I've got this 2-pack lacquer, and I'm going to marine grade varnish. I'm going to lacquer this whole surface area in here. No, this is the top one, so I'm only going to lacquer around the edges, and there's a faint lacquer on this. You see little wisps go through it, so it's not totally. It's obviously got impurities or whatever, and there's little holes there. So that's how I want to get the charges on it. I'm not going to lacquer here as well. This is where the wire comes in and touches. So these all stack together and they all touch each other and they all become connected. When you put and that's where that paint made it. Without that paint, it wouldn't, I couldn't get a good, but if I put a meter on here and measure it, it's a really good conductivity. There is the tube I was talking about. You can't 3D print that tube. I've just used, these are skewers, little timber skewers, just to get everything lined up when you slide it all together. That's a electrical thing that you buy from the shop. That one, yeah, so anyway, that one. Now all of these, here's the ring. So this spacer ring had to go in to give me a bit more room to fit this part in. So I had to put a spacer ring in so it didn't, anyway, that's that. Yeah, then they all just stack on each other. Here's the electrical tube. So they all just stack on and they all line up. And you can see under here, I have the aluminium comes down through the hole and touches one underneath, so lands on the top of the next one. It's connected, so they're all interconnected with paint or with aluminium or with whatever you can get. I was originally going to use a metal wire here and have it connect all of them, but I thought, I did it with this and it seemed to work, so I didn't worry about it too much more. That's that. So I'm going to go through that over the next couple of days, clean all the edges off and stop this sparking as much as I can. It's the 6 disc, 1, 2, 3, 4, 5, 6. It's this guy here that's giving me the trouble, I think. But I'm going to do all of them, so it won't matter. Look at that. It's hard to see, I'm losing my vision, I can't see this stuff. Anyway, so I'll go through, I'll work on that, and we might get 200,000 or 300,000 volts and burn some terminals. Alright, thanks for watching.